Welcome. In today's session, we are going to look at the histology of the cerebellum. And by the end of this session, you should state the layers of the cerebellar cortex, name some cell types within each layer of the cerebellar cortex, and you should describe how neurons connect within the cerebellar cortex. Now, welcome all. My name is Wallace Munyeri, and I'm the URE doctor. Now, this is gross anatomy. This is your cerebellum here. Cerebellum is the Latin for little brain. You can see this is the cerebellum. This is the brainstem. You can see this is the midbrain, pons, medulla. Then you have the fourth ventricle here. Then here you can see the superior medullary verum. The inferior should be here. Then you can see how the cerebellar cortex, its surface is slightly folded to form folia. Okay, that was just by the way. Let's continue. Now the cerebellum. Cerebellum is the Latin for small brain. It's highly folded to accommodate millions of neurons in a small area. So folding is just to increase the surface area. Cerebellum usually have two cerebellar hemispheres that are connected to each other by a median vermis. Now this is the left cerebellar hemisphere, and this is the right cerebellar hemisphere. You can see the two are connected by this vermis, and you can see vermis has several parts. Like this is the pyramid of vermis, this is the tube of vermis, then but this is the vermis. That is the point. Now let's look at the gray matter of cerebellum. Now most of the gray matter of the cerebellum is arranged as a thin layer covering the central core of white matter. This layer is the cerebellar cortex. So the outer gray layer is the cerebellar cortex. The subdivisions of the cerebellar cortex correspond to the subdivision of the cerebellum. Embedded within the central core of white matter, there are masses of gray matter that constitute the cerebellar nuclei. These are, we have 4 nuclei: the dentate nucleus, the embodiform nucleus, the globose nucleus, and the fastigial nucleus. Now, these 3, dentate, embodiform, and globose nucleus, they send their efferent fibers via the superior cerebellar peduncle, but the fastigial nucleus is the only one which sends its efferents via the inferior cerebellar peduncle. But you can find other texts which refer the globose nucleus and embodiform nucleus together as nucleus interpositus. Okay, maybe that is something you should know. Now here is a diagram showing where they lie. You can see how dentate nucleus is a crumpled. It looks like the crumpled appearance. It is the most lateral. Then we have embodiform. Then we have globosus. Then the most medial is fastigial. Okay. Then you can see how the surface is highly folded to form folia. Then you can see this core of white matter. It has a tree-like pattern. You might find some texts which call this tree-like pattern of the white matter abovitae cerebelli. I will show you that. Now the white matter of cerebellum. Now the central core of each cerebellar hemisphere is formed by white matter. The peduncles are continued into this white matter. Now then the white matter of the two sides is connected by a thin lamina of fibers that are closely related to the fourth ventricle. Now the upper part of this lamina forms the superior medullary verum, and in its inferior part forms the inferior medullary verum. Both these take part in the forming of the roof of the fourth ventricle. Okay. Now, the white matter of cerebellum forms a tree-like pattern, as I have said, known as the abovitae cerebelli. Okay. Abovitae means tree of life. So it is tree of life of the cerebellum. Now let's look at the cerebellar cortex. Now, the structure of the cerebellum is uniform or homotypical. It is uniform throughout. Now, the cerebellar cortex shows 3 layers: outer molecular, middle Purkinje cell layer, and the inner granular layer. And here they are. This is the outer molecular. Then here you will see a very thin layer. It is one cell layer, the Purkinje cell layer, then the granular layer here. Okay, under this magnification, you can see them. Now this is the outer molecular layer. Then here we have the Purkinje cell layer. Then this is your inner granular layer. Now let's look at each layer. Now the outer molecular layer. The molecular layer usually lie just deep to the pia mater. It is a lightly stained layer with hematoxylin and eosin stain. It contains few cells. It has few cells and more fibers. Okay. Now, what are the cell types in the outer molecular layer? You find two cell types. Now, molecular layer has sterate cells on the superficial part. So, if this is the superficial part, okay, here you find sterate cells. Okay, then in the deeper part, we'll have the basket cells. So the basket cells will be somewhere here near there. Now this is a Purkinje cell here, and this. So this is a Purkinje cell there. Then this is your inner granular. So this is your outer molecular. So in the deeper parts of the outer molecular layer, you find the basket cells. Which fibers are found here? Fibers, you will find numerous dendrites of the Purkinje cells. You will also find axons of the granule cells. You will also find cribin fibers. So this, I will at the end of this session, we might talk about how these fibers are connected. Now let's look at the other layer, the Purkinje cell layer. This layer consists of a single row of Purkinje cell bodies that are arranged between the molecular and granular layer. These Purkinje cells were discovered by this guy, not discovered, they were first seen by, okay, maybe they were discovered. They were first seen by this guy known as Jan Evangelista Purkinje, who was a Zech anatomist. So he lived between these years, and he observed them, so they were named after him, Purkinje cells. How will you identify Purkinje cells? They are usually large, and they have flask-shaped cell bodies. Here you can see this cell body here, it is flask-shaped, and it has a note that this is its dendrite, an apical dendrite here. Okay, it has a dendrite. This is its dendrite. Okay, then it usually sends its dendrite into the molecular layer, and the dendrite will undergo arborization. It will branch several times, very many times. That is known as dendritic arborization. Okay. Now, dendrites of the Purkinje cell arise from the apex of the flask and enter into the molecular layer. Now, a single axon usually arises from the base of that flask-shaped body, then passes through the granular layer and white matter to the cerebellar nuclei. Note that the axon of the Purkinje cells is the sole output, is the only output of the cerebellar cortex. Please note that. Now, the supporting cells, this is a very important point. The supporting cells of the Purkinje cell layer are known as the Bergman cells. Okay, please note that. And here you can see a single layer of those cells, Purkinje cells. Okay, like this is a very good Purkinje cell there. You can see it is flask shaped. And this its cell body here. Is flask shaped. Now let's look at the final layer, the granular layer, which lies between the Purkinje cell layer and the white matter. It usually stains dark with the hematoxylin because of closely packed numerous small granule cells. Okay, these are the granule cells. There are very many. Now, which are the cell types? It has granule cells and Golgi cells. Okay, granule cells are smaller neurons with round nucleus, while Golgi cells are larger and they are somewhat sterate shaped. They are sterate shaped. Now, which are the fibers in the granular layer? Granule cells granular layer. The granular layer has mossy fibers, and like the mossy fibers terminate in the granular layer, but the cribin fibers terminate in the outer molecular layer. that usually bring information from pons to granule cells, or the pontocerebellar fibers. Crybin fibers just pass here, they do not terminate here. Then you also have axons of the Purkinje cells as they move from the outer molecular layer towards the white matter. They just pass through the granular layer. Now let's go back. Here, this is the inner granular layer. You can see there are some spaces, there are some unoccupied spaces between these granule cells. Those are known as the cerebellar islands. Okay, now within those cerebellar islands, we have these special synaptic structures which occupy the cerebellar islands, known as the cerebellar glomeruli. Okay, what makes up a cerebellar glomeruli? We have the dilated end of a mossy fiber known as a rosette. Okay, we also have, which is usually surrounded by dendrites of granule cells, a dendrite of granule cell, and an axon of Golgi cell. Okay, so these make up at the cerebellar glomeruli. The dilated end of the mossy fiber known as a rosette, the dendrite of granule cell, and the axon of Golgi cell. Okay, those structures make up the cerebellar glomeruli. Now this is a table summarizing that. We have stated cells just found beneath. They are found in the outer molecular layer, the superficial part, then basket cells in the deeper part of, outer molecular layer, then Purkinje cell in the Purkinje cell layer, granule cells in the granular layer, Golgi cells in the superficial part of granular layer. How will you identify? The stellate is a small neuron, basket has a small nucleus, large flask-shaped cells, small spherical neurons, they are large stellate cells. Okay, maybe you can pause the video and look at this on your own. Okay, I urge you to please know where their axons and dendrites terminate. Then let's look at the cerebellar connection. Now, the afferent fibers to the cerebellar cortex are of two different types. It can either be mossy fibers or climbing fibers. Now, all fibers entering the cerebellum other than olivocerebellar end as mossy fibers. So, all fibers which enter the cerebellum, such as the vestibulocerebellar, pontocerebellar, spinocerebellar, all those pathways, all those tracts, they terminate as mossy fibers, and they usually terminate in the granular layer of the cortex within the glomeruli. Okay, remember the mossy fibers, the terminal end of the mossy fiber will dilate to form the rosette in the cerebellar glomeruli. Before terminating, that is, they usually branch profusely within the granular layer. Each branch ends in an expanded terminal called the rosette. Now, afferent inputs through mossy fibers pass through granule cells, okay, to reach the Purkinje cells. Okay, remember the dendrite. You find a dendrite of the granule cell in the synapsing with the rosette in the cerebellar glomeruli. Then it will send its axon to the outer molecular layer, where the axon will synapse with the dendrites of Purkinje cells. I will show you that in a diagram and you will understand very easily right now. Now let's finish first here. This is the Crybin fibers. Crybin fibers represent termination of axons reaching the cerebellum from the inferior olivary complex or the olivocerebellar tract. They usually pass through the granular layer and Purkinje cell layer to reach the molecular layer, where they will synapse with the dendrites of the Purkinje cells. Now, each Crybin fiber exerts a specific influence on one Purkinje cell. Now, let me show you that. Here, you can see this is a Crybin fiber from olivocerebellar tract. You can see it is passing through the granular layer, then it will pass here through the Purkinje cell layer, then it will synapse with the dendrites of the Purkinje cell. Then the Purkinje cell will send its axon to the cerebellar nuclei. Okay. Then here you can see a mossy fiber which is terminating here in the glomerulus. This is the terminal expansion of the mossy fiber, the rosette. Then the rosette, within the rosette will synapse with the dendrite of granule cell. Then the granule cell will send its axon, okay, which will bifurcate within the molecular layer and synapse with the dendrites of Purkinje cell. Also, here you can see the this is the dendrite. No, this is the axon of Golgi cell. We will synapse with the rosette here. Then it will send its axon to the molecular layer, and it will sign up with the axons of the granule cells. Then this is the sole output. Okay, this is the sole output of the cerebellar cortex, the axons of the Purkinje cells. Then they will go to the cerebellar nuclei. Then the cerebellar nuclei will send their efferents to other parts of the brain. Now, thank you for your attention. I hope you have understood. And please subscribe for more anatomy and biochemistry content. Thank you.